Hello and welcome to today's lesson on pressure in fluids. In this lesson, we'll begin by reviewing pressure, which we introduced in the particle models of matter unit. We'll then develop our understanding of the directions in which pressure acts in fluids. Let's get started. Pressure is a fundamental concept in physics, especially when considering forces in fluids, which include both gases and liquids.
So what is pressure?
Pressure is defined as the force exerted by a substance on a surface per unit area. Essentially, pressure is how much force is being applied over a specific area. In fluids, the particles are in constant motion, colliding with each other and any surface they come into contact with. These collisions result in a force being applied over a specific area. Basically, these collisions result in the exertion of pressure. When a fluid exerts pressure on a surface, this pressure is always directed perpendicular to the surface. This means that the force due to pressure acts at right angles to the surface it encounters. Additionally, unlike solids, in which forces often act in specific directions, fluids exert pressure equally in all directions. This is due to the fluid's nature, where particles are free to move around and distribute forces uniformly. To visualize this, imagine a swimmer diving into a pool. The water in the pool exerts pressure on all parts of the swimmer's body that are submerged. This pressure acts uniformly and evenly, pushing against the swimmer from every direction. Whether the swimmer is facing up, down, or sideways, they will feel the pressure of the water acting equally from all directions. In today's lesson, we delved into the concept of pressure in fluids, including both gases and liquids. We reviewed that pressure is defined as the force exerted by a substance on a surface per unit area, and discovered that this pressure is always directed perpendicular to the surface it encounters. We learned that fluids exert pressure equally in all directions, which was illustrated using the example of a swimmer diving into a pool. We also revisited the formula for calculating pressure, which is pressure equals force divided by area. Understanding pressure in fluids is crucial for grasping many physical phenomena and practical applications, from the functioning of hydraulic machines to the effects of atmospheric changes on our bodies. This knowledge not only deepens our understanding of forces, but also enhances our appreciation of the role fluids play in the natural world. Watch the rest of the GCSE physics course at Sophos Education.